There's this quiet but absolutely massive revolution happening right under our noses, inside our energy infrastructure. A huge shift is underway, and it's being supercharged by one of the most futuristic technologies you can imagine, quantum computing. So let's just jump right into the big question. What actually happens when our power grid gets a quantum grain? And no, this is not science fiction. We're talking about combining these small, local energy grids with the mind-bending power of quantum computers. And the results? They're already proving to be a total game changer. To really get a handle on this, we're going to go on a bit of a global tour. First, we'll get our terms straight. Then, we're off to Israel to talk about battery life, over to China to see how they handle grid coordination. We'll take a global look at storm recovery, and then we'll land in Germany to see the future of community power. Ready? Let's go. Okay, first up, quantum meets microgrids. This is really a story about resilience and, you guessed it, autonomy. We're bringing together two key players, the nimble local microgrid and the incredibly powerful quantum computer. So, what even is a microgrid? Well, the easiest way to think about it is like a neighborhood-sized power island. It's a local, totally self-sufficient energy system that can, and this is the key part, disconnect from the main grid and just operate on its own. That autonomy is absolutely crucial when things go wrong. Our first stop is Israel. Here, researchers are kind of acting like battery whisperers. They're tackling what seems like a small problem, battery longevity, but it has massive implications for the entire renewable energy industry. Okay, so here's the core issue. For any grid that's heavy on renewables, like solar or wind, batteries are everything. But constantly charging them up and draining them down just wears them out. This wear and tear is a constant headache, It leads to expensive replacements and potential failures. So the team at QuantyMize asked a brilliant question. Could a quantum computer manage this whole process better? And the result? Well, it's pretty astonishing. A 40% reduction in battery wear and tear. Get this, 40%. That's not just a tiny improvement. That is a fundamental leap forward in making our energy storage last. So, what does a number like that actually mean in the real world? Well, it's huge. It means batteries last way, way longer. It means the physical infrastructure of the grid is better protected. And maybe most importantly, it means a much, much lower risk of blackouts right when we need the power most. All right, let's head to our next stop. We're zooming out from a single battery system to the huge, wind-swept region of Xinjiang, China. Here, the problem isn't about one component, it's about solving a massive coordination challenge. The whole challenge here is turning the chaos of renewable energy into a perfectly timed symphony. See, on one side, you've got these unpredictable inputs from wind and sun. It's a total cacophony. The goal is to use a quantum computer to transform all of that into a coordinated, reliable, and cost-efficient system. And this, right here, is the core challenge of renewables at scale. So how in the world do they do it? They use a tool called the Quantum Approximate Optimization Algorithm, or QAOA for short. Just think of it like a super intelligent predictive scheduler. It looks at countless possibilities and finds the best way to route energy. It's all about adapting to the future, seeing cloudy skies or gusty winds coming and adjusting the energy flow before the grid ever feels a thing. Okay. Our third stop tackles a completely different kind of problem. We're not talking about day-to-day optimization anymore. Now we're talking about a crisis scenario. How do you recover fast after a major storm just knocks out the power? This is all about resilience. This is where a hybrid solver shines. It's basically a team-up. Classical computers do the initial data crunching, and then a quantum processor steps in to handle the impossibly complex part, analyzing all the damage and finding the single fastest, most efficient way to reroute power. The goal? To get service back up and running in record time, right when people need it the most. And for our final stop, we're off to Germany. We're going to look at a project that's less about top-down control and much more about empowering entire communities. They're trying to build something called an energy commons. I just love this quote. It perfectly captures what the QGrid project is all about. This isn't some big utility company telling everyone where the energy goes. It's more like community choreography, where local neighborhoods get to dynamically manage their own power.
So what does that actually look like? It means neighborhoods are forming their own peer-to-peer energy networks. I mean, your rooftop solar panels could be sending extra juice directly to your neighbor's electric car charger. And quantum computing is the invisible conductor making it all possible, enabling a true kind of local energy democracy, where grids can literally organize and even heal themselves.
So, wow, we have been on a whirlwind tour. Now it's time to connect all these dots and really talk about what this energy awakening means for every single one of us.
This table really sums up our entire journey, doesn't it? In Israel, quantum computing tackled battery life. In China, it brought precision scheduling to all that renewable chaos. Globally, it's helping us recover from disasters faster. And in Germany, it's building a future of decentralized energy democracy. Each place is solving a different, crucial piece of the puzzle.
And if there's one thing to take away from all this, it's this. These are not just isolated experiments happening in a university lab somewhere. These are living, breathing projects out there proving that quantum technology can solve real-world energy problems right now. The future is definitely arriving a lot faster than we think.
So I'm going to leave you with this one last thought. Let's forget the global scale for just a second and bring it right back home to your own street. If your neighborhood had the chance to generate and share its own power, to become more resilient, more self-sufficient, would you join in?